हरि करना।
So as we have understood that uh, the warts method is preferred more than others in clustering because the ward method attempts to minimize the sum of the squared distances of the points from the cluster centers compared to the distance based measures described in average method, min max linkage methods. So the word method is less susceptible to noise and outliers. So that's the reason Watt's linkage is preferred more than others in clustering. Anyhow, so let's deep dive into the Watt's linkage. Whatever example that we have done for the Watt's linkage with SciPy, we will also do with the sklearn, and we will try to visualize the clusters also. Okay, we'll just put the clusters, we'll classify the clusters also. Okay, let's put the whole process into at one place. So let's bring everything and let's add bits and pieces. So steps for agglomerative clustering, let's sum it up. So step one, compute the proximity matrix using a particular distance metric. Then each data point is assigned to a cluster. Then merge the clusters based on a metric for the similarity between the clusters. Then update the distance matrix and repeat. Then the next step is to repeat the step 3 and step 4 until only a single cluster remains. And after doing that, in the third step, we have used single or min linkage method, complete or max linkage method, average linkage, and word linkage methods and centroid linkage methods, and these are the results. But I find word linkage is giving the better results, so that is the reason. Let's explore more about that. Okay, let this time we are gonna use sklearn library. To do the same, we will take up the same example with the same data, but let's do it in sklearn so that we can so that it seems we have used both libraries, scipy as well as sklearn. Okay, from sklearn dot cluster and import agglomerative clustering. So that's that's what agglomerating clustering module has been imported. Now it's time to instantiate the class object. Let me call it as it's word method. So let me go for the word linkage. Obviously, that's what. Okay, I'm gonna give the better name for this, word link agg, and let me instantiate the agglomerative clustering class object. So how many clusters you want to have? I'm going to go for the 2 clusters for now. Later, let's play around, but for now, we'll go. I'm going to go for the 2 clusters and linkage. Obviously, I'll go with word. Yeah, word. Okay. So let's do the self testing. If underscore main, if you want to know the print type of, okay, let me change this to small. Yeah, and let me execute. Okay, so now let's move ahead. Let me say word link aggregate. Now I need to fit the data into that. Obviously I need to use a fit method so that I can try my algorithm and convert that into model. So fit, so fitting the data into it, x1. So the fit has been done. Now it's just time to print the labels. So what link aggregate, and let me say labels underscore, and here is your labels. So total data points has been labeled into two clusters: zeros, one, zero, one cluster, zero cluster, one cluster, zero cluster, one cluster. So it's been split into two clusters. Fantastic. So now let's try to visualize the same. So let me take up visualizing the two clusters. So nothing, whatever we have done the same example. Okay, but there also we got the two clusters, but there we did it with SciPy library, and now we are doing with sklearn. There with SciPy library and now with sklearn. Okay, so fig comma ax is equal to plt dot subplots, and let me go for the fig size. Fig size, let me give it tuple under that 6 comma 6, and here is your fig size. Okay, absolutely fine. Now let me create a scatter plot. Scatter plot is equals to ax dot scatter, and obviously let me take up the same data, same format that I have used before for the scatter plots. From here, where is that? Yep, here is that. Check this arguments. Let me check these arguments. Yeah, x1, and only the color. So let me go for the what link aggregate, and I'm going to give the labels, and cmap is equal to, I'm going to go for the rainbow. Okay, and so let me add a legend. Legend is equals to x dot legend, and just a minute. Yep, scatter dot legend underscore elements, and title is equals to clusters, and bbox underscore to underscore anchor is equal to 1 comma 1. So that's it. Most of the things are done. It's time to add access add artist. So legend, and let me add a title now. Plt dot title is scatter plot of clusters. So now it's time to show it. That's it. Rest all are done. Plt dot show. So what there? Okay, there is some issue here. There is, okay, elements additional D. There is, okay, I got the plot, but legend, okay, Okay, that's it. It's all done, all set. So overall, your 8 data points, it's been made into 2 clusters. This is your blue ones are cluster 0, and these are cluster 1. Cluster 0 and cluster 1. That's it. And it makes more sense to certain extent. So where, okay, this is cluster 0 and this is cluster 1. So what method is better than other methods for many cases, but before you decide to go with any certain case, kindly do the required analysis.